we can highlight this idea of like terms or like radicals. And in order for two things to be like radicals, they need the same inside and the same index. So just like when you're in polynomials, adding and subtracting like terms, you had to have the same variables with the same exponents. The same thing is true with radicals. So if we look at part A, it says to simplify 9 root 5s minus 4 root 5 root 5s will end up giving us 4 root 5s. And now that one was extra easy because the radicals were already like radicals. But if we wanted to do things that sort of steps, first thing, you want to find out what families things belong to. So the first thing you're going to have to do is simplify as mixed radicals. So you find the smallest family, like root 8, we found out from our activity was 2 root 2s. And root 2 is the basic family that root 8 belongs to. So we simplify first as mixed radicals, then we can combine like radicals. So in part B, currently none of those cube roots have the same number inside. They all have the same index, but they're not like radicals at this point. So we have to break them up. So we go to our powers chart. Can you divide anything, any perfect cube divide 24? Yes, it is 8 times 3 minus. Now 192. And I'm actually going to off to the side here. Don't write this down unless you really want to, but I'm going to show you that with the cube root of 192, it might take you down 2 different paths. First of all, it's a big enough number that you probably take out your calculator and start checking. Can you divide 192? Your first perfect cube is 8. Does it work? Yes. So we might go down this path. This is very typical as a first step, changing it to the cube root of 8 times 24. But I want to show you that if you started checking bigger perfect cubes, like after 8 is 27, doesn't work. After 27, 4 cubed is 64. Ooh, it's a nice number as well. So that gives us a secondary option here that we could have also have done 64 times 3. Is one better than the other? Maybe. I kind of like the second one because when you cube root 64, you get 4 cube root of 3. If you do the first one, when you cube root 8, you get 2 cube root of 24. And one of the things we have to practice when simplifying is after you simplify, check again. Now 3 is obvious that you can't divide it by any perfect cube, but 24, we could have kept going. Because 24 is 8 times 3, and the cube root is 8 is 2, so when I pull out another 2 in front, it would multiply that other 2 and give me 4, and I get 4 cube root of 3. So ideally, if you can find the biggest perfect cube, that makes your life easier, because your simplification is easier. However, sometimes you don't see the biggest one. So it's always important after you do a simplification to look inside to see, could I go further? Because sometimes you see something. I think a great example, 72. What times what is 72? With a perfect square. 8 and 9. Almost everybody sees 9 and 8 first. What also would work? 6 and 12 would work, but it's not a perfect square. So we wouldn't use 6 and 12 when solving a square root, but 36 and 2, 36 is a perfect square. Now this one gives me 3 root 8. This one gives me 6 root 2. the 3 root 8, you'd have to keep going. But if you're a typical student, once you do something, you feel so proud of yourself, you just like move on and don't double check things. So lots of students lose marks on the 3 root 8 because they stop. But this square root of 4 could come up, and it should be 6 root 2. And that's why at the top here, simplify, we could add in lowest terms to make sure that we don't run into that problem. So I'm going to erase this. We're going to keep going in our question. 375 is the cube root of 125 times 3. And now cube root of 8 is 2, so I get 2 cube root of 3. Cube root of 64 is 4, so I get 4 cube root of 3. And cube root of 125 is 5, so I get 5 cube root of 3. And now they're all like radicals, so I can put them together and get negative 7 cube roots of 3. And for part C, we have square roots. Now some of you get really good, you could probably simplify them in your head. That's perfectly fine. I'll show the extra work. But 63, is there a perfect square that makes 63? 9 and 7. And then scroll up so I can actually see it. Plus 40. How'd you break up 40? The perfect square that divides 40? Which ones? 4 and 10. Minus 90. 9 and 10. And 28. 4 and 7. So that makes this 3 root 7 plus 2 root 10 minus 3 root 10 minus 2 root 7. And now we can combine our like terms. 3 root 7s minus 2 root 7s would leave you with 1 root 7. Are you okay if I write 1 root 7 without the 1 out in front? You can write a 1 out in front, but at 1 root 7 is just root 7. So I have 3 root 7s minus 2 root 7. And then 2 root 10s minus 3 root 10s will be minus 1 root 10. And this is simplified completely. All right, circle question 3, 4, and 9. And you can